morning. We are going to go to infinity and beyond today. So, limits involving infinity. Oh, shoot. I can't spell. Infinity. There we go. So, every time we have a limit involving infinity, it is going to be a asymptote. So that's the super cool thing about infinite limits. You're going to either get, if you go to infinity, you're going to get a vertical asymptote. If you have a limit at infinity, you get a horizontal asymptote. So let's look at vertical asymptotes first. So definition of an infinite limit. So infinite limit. The limit as x approaches some number a of f of x is equal to plus or minus infinity. All right, and put a box around that. That's important, right? And this gives us a vertical asymptote. So it's kind of cool when you do the limit like this. It gives you information about the graph. So let's do a quick example to show you how that works. So the limit as x approaches 2 of 3 over x minus 2 is equal to, well, what do we do for limits? You're right, direct substitution. So we plug and chug, right? We take that 2 and we plug it in for x. So we get 3 divided by 2 minus 2, get 3 over 0, and that is equal to dne, right? So we cannot divide by 0. So anytime you get a number divided by 0, you have a vertical asymptote. So immediately we could draw something on this graph, right? We can say at x equals 2, we have a vertical asymptote. VA equals x equals 2. So we could draw it, 1, 2, 3, 4, say, and we can draw this asymptote on our graph. Okay, but are we going to positive infinity or negative infinity? What the heck does this graph look like, right? So that's where you look at the one-sided limits to determine more information, right? One-sided limits. So we're going to look at the limit as x approaches 2 from the left, right? From the left side of 3 over x minus 2. So now we sort of like think about this in terms of a number really close to 2, but not 2, right? And from the left side, meaning over here, it's going to be really close to 2, but slightly smaller, right? Okay, so we're going to plug in a number, plug in number close to 2, and then but smaller. So that's our thinking bubble there, right? Okay, we're plugging in a number like 1.9, say. That's going to be a really small negative number, right? Like negative 0.1, right? A really small negative number. So this is going to then go to, absolutely right, negative infinity, right? Negative infinity. So from the left, we're going down towards negative infinity, right? Okay. And then we're going to check it from the right, right? So now the limit as x approaches 2 from the right, 3x minus 2. Now we're plugging in the number from right here, right? So now we're plugging in a number really, really close to 2, but not quite 2, right? So, but slightly bigger, right? Plug in number close to 2, but bigger. Like 2.1. And this one we did 1.9, right? And so now we got 3 over a positive 0.1, which goes to positive infinity. Yeah, I shouldn't put an equal sign there, should I? I'll put an arrow, right? Because we're just thinking in terms of kind of generalities here. Oh, we can't see that. There we go. Okay, so now we see, oh, okay, so from the right side, then we're going to positive infinity. And if you remember what this might look like, 3 over x minus 2, it's similar to 1 over x. And you know 1 over x looks kind of like this. It's got this nice curve on the right, and then it flips down to something like this on the left. So something like that. And I shouldn't be touching that asymptote. Ah, messed up there. Probably should be right there. Okay, so very cool. You can use these infinite limits to tell us what the graph looks like and tell us about vertical asymptote. So the thing you really, really need to remember is vertical asymptote occurs when limit is D and E, right? Now be careful. If you get 0 over 0, that's not D and E. It has to be a number over 0. That's D and E, okay? So let's do an example. How do we know if it's a vertical asymptote or a hole, right? So now we're going to do another example, a little bit more difficult, right? Is it a VA, vertical asymptote, or a hole? How do we know, right? Okay, so let's say we've got something a little bit more complicated. X minus 2 tangent of 5x over x squared minus x. Oh, now it's getting interesting, right? Okay, so our steps to determine where's the vertical asymptote, what's the hole, you are going to set that denominator equal to, yeah, you're right, denominator equals 0, right? Because that's when you're going to get that D and E, right? And that's going to determine the vertical asymptote. And then when we do that, we're going to get a couple of values. We're going to solve for x. Then the second step, though, this is the big step to determine whether it's a vertical asymptote or it might be a hole, right? Then you find the limit, just what we did in the previous example, the limit at those x values. Okay, let's do it. So I'm going to take that denominator, step 1, x squared minus x is equal to 0. All right, step 1. And we can factor that, right? x minus 1 is equal to 0, so x is equal to 0 or 1. Okay, so those are two potential asymptotes, and we don't know whether they are actually a vertical asymptote or they might be a hole. Right? There we go. All right, now step 2, limits. So we're going to check that limit. The limit as x approaches 0 of f of x, x minus 2, tangent of 5x. And I'm going to keep this factored version of the denominator because I like it. X and x minus 1. So I'm going to keep it like that. Oh, and then I'm going to also check x goes to 1 and x minus 2 times tangent of 5x for x minus 1 times x. Okay, and we're going to try direct substitution. So this one here, I'm going to plug in 0 for x. All my x's. And over here, direct substitution, and we try that, and we get -2 tangent of 0 all over -1 times 0. So we get 0 over 0. And that, remember, that's the indeterminate form that tells us absolutely nothing. Right? We call that indeterminate. Okay? Not determinate. It doesn't tell us anything. So now, if you guys can see, there's a kingpin. Remember our kingpins? There's a kingpin hiding in there. So we can split this into 2 limits here. So here I'm going to plug in 0. I'm going to do the limit of this one, which is -2 over -1. And remember the kingpin? Absolutely right. So that's 5 over 1. 5 over 1. So I got 10. This means that it's a whole. If you get an answer, it's a whole. It's not infinity, right? So we have a whole at 0, 10. This one, though, let's do our direct substitution. You guys can see the difference here. We get 1 minus 2 tangent of 5 times 1 over 1 minus 1 times 1. So here we get a negative tangent of 5 over 0. You can see that negative tangent of 5, that's going to be just a number, right? Some number over 0 is d and e. So we have a vertical asymptote at x equals 1. So vertical asymptote and a whole. So that's our difference. All right. Next video is going to be if we have a limit at infinity.